In this video, we are going to find the formula for the inverse of each function. The first example that we'll do is fairly straightforward. The second example follows the same principles, but is rather complex in the algebra. So let's get started. There are two things that we need to do in order to find the inverse. The inverse reverses the roles of the variables, so we'll start by switching our x and our y. So I'm just going to switch them and rewrite this, but where there is a y, I write x, and where there is an x, I write y. So that is my first step in finding the inverse, doing the switch. Second step is to solve for y. So I need to rework this equation so that it is in the y equals format. First thing I'll do in order to solve for y is add 9, and that will take this to the other side of my equation. I have to keep my equation balanced, so I add 9 to both sides. These guys cancel. True inverses. These are not like terms, so I start with that formula. X plus 9 is equal to 5y. Now there's one more step in order to get this in the y equals format, and that is to divide by 5. So I'll divide by 5 on both sides. Notice how my fraction bar goes under everything there. These guys cancel, true inverses of multiplication and division, and so I have y equals x plus 9 divided by 5. If I want to put this into function notation and I want to indicate that it is the inverse, I can use the f with a little -1 indicating the inverse of f of x is the function x plus 9 divided by 5. Now if I look at my original function was x was multiplied by 5 and subtract 9. And when I look at the inverse, you can see how it's opposite. Instead of multiplying by 5, we're dividing by 5. Instead of subtracting 9, we're adding 9. And using this two-step process where we first off switched the variables and then resolved it for y equals allows us to find that formula for the inverse. So we're going to try our second example. Our second example you can see is more involved. So the second example, we immediately have this function notation, and I'm going to replace that function notation with a y. Now this is not switching variables, this is just replacing because f of x is in the same position as the y. Once I've done that, then it's easier for me to switch my x and y. So again, I start by switching. I'm going to start over here so I have a little bit more space. So instead of y, I write x. And so then I have 2. Instead of x, I write y plus 7. In the denominator, I have 7. And again, instead of x, I write y minus 9. So this is my first step where I switched the variables. My second step is to get this in the format y equals, but when I look at this equation, it's rather complex. I do have a fraction here, and so when I have a fraction, I prefer to make both sides into fractions and use the cross product. So I'll multiply on the two diagonals. So from the top to the bottom, moving left to right, I have x, parenthesis, 7y minus 9. And again, moving left to right, this time bottom to top, I have 1 times this, so 1 times anything is itself, so 2y plus 7. All right, so now what I want to do is the distributive property because I have parentheses. So I distribute, I multiply to both terms, and that gives me 7xy minus 9x is equal to 2y plus 7. So I want to get y by itself. I have y in two different terms. Those two different terms are not like terms because this one includes the variable x and this one on the right hand side does not. Nonetheless, I still want them on the same side of the equation. I want anything that does not have a y to be on the opposite side of the equation. So I'm going to add 9x to both sides to move that away. On the left, these are like terms and they cancel. So I have 7xy is equal to, on the right, I do not have any like terms, so I cannot combine anything, but I can rewrite. All right. Now I want to take this 2y and move it over so that it is on the same side as my other y term. So I will subtract 2y from both sides. Here they cancel, true inverses. Over here they are not like terms, so I have 7xy minus 2y is equal to 7 plus 9x. Now this is the part that I feel like is a little bit tricky because it's not something we often do when we're solving equations. We're actually going to factor. And the factoring that we're doing is the reverse of the distributive. So in the left-hand side, I see here is a y term and here is a y term. So I can factor that out and pull it to the front, add my parentheses. Remaining in this first term are 7 and x. Remaining is the negative and the 2. So if I look between these two lines in my equation solving, I think it's easiest if I look from the bottom up. I can see that if I distributed the y, I would be right back up to this previous line. So what I did is, because they were not like terms here, I could not combine them. And so instead I chose to factor to get down to this line. Now that factoring is very helpful because I now have a multiplication, and the inverse of multiplication is division. So I will divide on this side by 7x minus 2 and do the same thing to both sides. And these guys cancel, leaving me with an equation that is solved out for y. So I have y equals, and I have on the top 7 plus 9x, and I have in the denominator 7x minus 2. If I want to write this in function notation, I can replace that y with an f inverse because I have switched the role of the variables. I have found the formula for the inverse. So f inverse of x is 7 plus 9x divided by 7x minus 2. Now, in this complicated example, I am not able to look at the original and the inverse and just understand exactly how those work in reverse of each other. We could do the proof, and we could prove that this truly is the inverse, but that is a lot of math. So why I put this on the video for you is because of all the algebra. And so I'm going to very quickly just go back through the algebra that led us here. First step, we rewrote f of x as a y, and then over here we switched x and y, and we did that in both examples. So that got us right here. Then we needed to solve for y as our second step. And that's where we ran into a lot of algebra. First thing we did was put this over 1 so we could cross multiply. We distributed. We got our constant term and our x term on the right-hand side. We got our y terms together on the left-hand side. And then this was the key thing. So from here to here, the step that we did was to factor. And we reversed the distributive property by pulling a y out to the front. Last we divided, and that allowed us to find the inverse.